All right, it's 10:01, so let's get started. Thanks everyone for joining us today. Appreciate you taking the time to learn more about Excel data. Welcome to our webinar about data reliability is much more than data quality. So we're going to start today with my colleagues, John Morrell, who is from product marketing, and he's going to take you through a few slides. And then also we have Joe Murphy, who is our senior solutions architect, and he's going to take you through a product demo. The program is probably going to be about 45 minutes, 50 minutes, and then we will take questions. If you do have any questions, please put them in the chat, and then we will answer as many questions as we can at the end of the webinar. We will also do 3 polls during the webinar as well, just to make it a little bit more interactive. So with that, John, why don't you take it away?
Thank you, Loretta. Obviously the world is always changing around us, right? Analytics is now a very mission critical aspect of everybody's, data operations. And, but one of the key aspects that becomes more important as analytics become mission critical is managing how reliable and how the level of quality of your data. And on the flip side of that, we've seen some surveys and some reports and others that have shown that poor data quality is truly impacting business operations. Harvard Business Review did a study that showed that only 3% of an organization's, the average organization's data meets the basic quality standards of 97% score or higher. And even if you kind of relax that a little bit, it's still only about 20% of data has quality scores of like 80 or higher. So it's really, our data quality isn't as good as we hope it would be, as good as it can be. And Gartner also did a research study that showed that, hey, if an organization has poor data quality, the average organization with poor data quality ends up, with about $15 million a year in losses because of that. So that's a significant chunk of change, a significant amount of money that organizations are losing because of poor data quality. And when you do have data unreliable issues, right, then it causes a lot of pain within the business. I mean, let's just first start out with poor data quality, right? If you have poor data quality, then it leads to very slow business decisions. It leads to inaccurate business decisions sometimes. And so the business starts down a path of making a decision and operating in a certain way when the data doesn't necessarily back that up properly. It also produces a lack of trust in the data. And so business teams may stop and say, you know what, I don't trust this data, so I'm just going to go on my gut instinct as opposed to really having data to back up their decisions. If data is not as timely as it could be, then the business teams aren't getting the data as fresh and as often as they need to make the proper decisions. And so, the data teams are missing their service level agreements that they've made, the handshakes that they've made with the business. And then if data is in an unknown state of poor quality or a lack of timeliness, et cetera, then it can also lead to governance and even compliance issues. I'll talk a little bit later about one of our customers who had a real big issue in and around trying to make sure their data met regulatory requirements and how they ended up having to raise the level of quality and reliability of their data in order to meet those compliance aspects. And I talked a little bit earlier about how analytics are now becoming mission critical, and the world of analytics is changing, right? We had this old world legacy data warehousing where you would kind of like do sort of semi-regular data checks just to sort of see, hey, is the quality really there? The data quality checks were really just sort of basic. And they only sort of looked for certain aspects. Can I make sure there's no nulls in there? Or can I make sure that there's no invalid data in there? It only worked at data at rest. As a matter of fact, data in the final consumption zone, the final data sets, as opposed to data as it moved through certain pipelines. And oftentimes, the business teams end up having to eyeball or run some manual checks on the data themselves because there just wasn't enough performance in the system in order to run regular automated checks. But in this new world that we're at, in what I would like to call modern cloud-based analytics, right? The data is flowing pretty continuously. So you need real-time or near real-time continuous checks on the data. The data is far more complex and far more advanced. So you need far more advanced quality checks, not just your basic, everyday, simple checks on whether it's got like valid data valence inside of it. You're going to work on 3 different types of data, right? You've got your data at rest, but then you've got your data in motion as it's flowing from your source systems all the way through data pipelines. And then finally at your data for consumption, the thing that people are going to pull into their reporting or analytics tools. You need to sort of check on data throughout the pipeline, because if data goes bad somewhere in the pipeline, then all it's going to do is proliferate through the rest of the pipeline and create more and more bad data. And the process needs to be automated. You don't have the time of day to be able to go through and do manual checks on data. Everything needs to be automated, and you need to be able to be alerted when problems happen. So data reliability is now what we like to call a process, but it's also an outcome, right? And with this process, you're trying to ensure that data is delivered on time with the highest level of quality that you can possibly produce, so that business teams can make their timely decisions, can make sure that their decisions are highly accurate, and that the data teams meet their SLAs to the business, so that handshake is constantly there and business teams can trust the data that is being delivered to them. And as is the theme for this webinar, data reliability is way more than data quality these days, right? Obviously, data quality is still a major aspect of this, right? You got to be able to do these data quality checks. But then again, you also need to monitor your data pipelines. If a data pipeline breaks down in the middle, not only does it impact data quality, but it means the data actually didn't get delivered to the right people. You also have to check on data cadence. How often is data refreshed? Is it timely enough, right? Are people getting the data when they need it? You also need to do things like data reconciliation. You've got multiple sort of rows of a particular data, set of data in multiple places, and you need to reconcile them to make sure that the data is all the same, regardless of where it's coming from. You also need to be able to do problem resolution. If a data incident occurs, if you get an alert, well, how can I figure out exactly what happened? And then there's also what we like to call drift, and that comes in 2 forms: schema drift and data drift. And what that really means is things change over the course of time. Schemas may change, so you need to understand when schemas change so you can adjust your downstream data pipelines. But then you may also have what's called data drift, which means data could actually move to out of bounds values. The values themselves might be quote unquote really valid, but statistically the data may move into different forms that are not necessarily reconciled well with the way the business is operating. So you have to look for statistical anomalies in the data these days as well. So before we move on, let's throw out our poll question number 1. If you could throw this up, Loretta, right? But how do you do your data reliability checks today? And by the way, check all that apply, right? So are they manual or visual? Do you do ad hoc SQL? Do you do regularly scheduled SQL? Do you do automated checks within your data quality or data reliability tools? So kind of take a quick second here and kind of answer the question. And so we can kind of get an idea of sort of, how you do things today.
Yep. Thanks, John. People are still answering the poll, so we'll keep it up a little longer.
Okay. So as the poll is up, let me kind of quickly move on a little bit, right? And so from Excel data standpoint, right, we provide a complete set of functionality for data reliability to help your organization, to help your enterprise across your entire data stack. And it all starts with visibility, right? We give you visibility into any data asset that you have. We give you the ability to monitor those data assets, but also monitor data pipelines as well. So we give you the ability to identify issues anywhere in those pipelines, identify issues anywhere in those data assets. And we also give you an extensive metadata catalog that helps you say, hey, look, these are the things I want to look at. These are the things I want to work with. And these are the assets that are most important for me to monitor and get visibility into. There's also a huge aspect of this that is data quality. But data quality today is not your old world data quality that was before. You know, data quality is far more complex than just sort of looking at simple quality checks, right? And so what we put into our product is a lot of automation, and I'll talk a little bit more about what that is, but very automated set of data quality policies and recommendations in order to help you understand, and advanced data policies to help you better understand what's the shape of my data. Is it really good? Is it of the best possible quality that it could possibly be? We also help you with data cadence. And what that means is, can we determine how fresh the data is? Can we determine how timely the data is? Can we determine how often the data has been updated? So we can make sure that the business users that are consuming the data are getting the freshest possible data. And then lastly, we also help you with problem remediation. And this comes back to something that we like to call multi-layer data. We don't just sort of understand what's going on within specifically your data layer, but we drill down into other layers, such as your compute and storage layers and other aspects, in order to help you stop and say, hey, look, here's exactly why this particular problem happened, and I can figure out ways in which I can fix this from ever happening again.
Here, John, you want to sorry, do you want to go just look at the results of the first poll there real quick?
Sure. So in that first check, right? Oh, it's good. Very few people are doing manual or visual checks. That's a great thing. Some ad hoc SQL, some logs from your data stack tools. A lot of it's automated in your data quality and DR tools. So that's great as well, right? Automation is always really critical to all of this. So those are some great ways in which people can help solve this problem. So one of the key things that Excel data does is what we like to call shift left data reliability. And if you think about sort of your modern data pipelines, right? And as they move from left, which is your raw data sources, all the way to the complete right, which is your data for consumption, data that's being consumed into your BI tools, your analytics tools, your reports, right? One of the key things you want to be able to do is identify and isolate data incidents before they move through the pipeline. So our ability to sort of monitor and analyze and understand data quality and data reliability as data moves early in the data pipeline gives you the ability to stop and say, hey, this data is not very good. Let's not replicate this poor data through the rest of the pipeline. Let's stop it here. Let's figure out what's going on. Let's drill into the issue and let's make sure we solve this. And then we can just restart the pipeline and get it rolling again so that we can make sure only good data flows through the system and only good data gets to the end users who are going to use this. And this shift left data reliability is new and it's very unique to what Excel data does. It gives your data teams the ability to really, again, make sure that everything is working properly and doesn't propagate bad data throughout your systems. The other key aspect that I talked about earlier is we give you this complete level of visibility into your sort of, call it, data operations, right? Not only do we give you the ability to understand what's going on within your specific data assets, but we also give you the ability to see and monitor and understand what's going on within your data pipelines. We cover all those sets of data, whether it's at rest, in motion, or ready for consumption. right? We have this automated inventory of all the assets. Just point us to your particular data sources. We'll read in the assets that are there, and we'll also automatically profile them. We'll classify the data. We'll tag them for you, et cetera. And then we'll also help you figure out the data lineage. So how the data flows through that, so you can track that as well. We also help you increase your data quality coverage. And what I mean by that is, again, I mentioned earlier, if you have to do a lot of work, whether that's manual or even within your kind of like your old world data quality tools, it takes a lot of effort to set up data quality checks. And you also need to sort of stop and say, what type of data quality checks do I need to do? And let me manually put them in my data quality system. Well, what Excel data does is it actually helps read your data and make a lot and automate a lot of the processes and make a lot of recommendations in terms of how you should check for quality on this data. Things like anomaly detection. We have a deep set of profile on the data. We could keep a lot of statistics on the data and each column of the data and the values in that data, so that we can make these recommendations to say, here's data that might be out of bounds that you want to check for, or here's data that will necessarily not be of a valid value. And that's just simple examples, right? But we have this extensive automation and these recommendations. Then we also allow you to stop and say, look, these are a set of data policies that I want to apply across practically any data asset that I have. And I can stop and say, look, here's a set of data assets that I've classified as, of form X, right? And I want to apply these same data policies to all of these. And so you can apply these in bulk, which helps make your team far more efficient and effective in terms of how they apply these data policies. And again, we've got these advanced data policies, data drift, schema drift, data reconciliation, that really, really helps you apply a much greater coverage on your data and improve the overall quality of it. We also have this multi-layered data, which helps you not only sort of say, hey, here's what sort of happened to an asset, but here's what was happening with the underlying system, or here's what was happening within the particular component of your data stack that was processing this data at the time. And we can take all this data and correlate it together to help you drill down into problems when they occur, identify the root cause of those problems, and then stop and say, hey, I know how to fix this. I need to make sure that when I'm processing this component, I might need a little more compute time to be able to do it. Or I might need a slightly larger Snowflake instance when I'm processing this piece of my data pipeline or processing this particular set of data assets, right? So I can figure out how to optimize it more effectively. I can figure out how to make sure these problems don't occur again. And then also I can get problem resolution by having this cross data source reconciliation. I can make sure that data is properly in sync so that I don't have to do these manual checks on all of it, and make sure the problems are resolved as quickly as possible. We also have, again, this notion of data cadence and the ability to ensure that data is extremely fresh and is delivered in a timely manner. I've worked with customers in the past whose business models are predicated around really, really fast decisions based off of fresh data. One of my customers is a company that did small business loans, and they guaranteed they'd get you a decision within an hour and guaranteed the data would get delivered to you. I'm sorry, not the data, the money, the loan would get delivered to you within 24 hours. Well, in order to do that, you need to make sure you've got very timely and fresh data. You can't be making decisions off of stale data when that's your business model. So you need a high degree of data cadence to understand when data assets are being updated, how often are they being updated? Do I need to increase the speed by which those are updated? You can also monitor and get alerts on your pipeline execution. Is a particular node within that pipeline not exactly working to perfection, and how can I potentially optimize it? And I can drill down and identify issues and optimize how that data flows through so it does get there in a timely manner, and you can operate these far more advanced business models. And the other key thing Excel data gives you is this big, huge operational control center for your data, right? It gives you a single pane of glass for all your data assets. You can tailor and understand what types of alerts, reports you get. There's a whole bunch of integrated dashboards across a variety of the data reliability functions and controls that you need. And then, as I mentioned, that ability to stop and say, hey, here's a problem. Let me drill down and sort of see what it's at. It is really like, you know, I used to work in the networking business as well, right? And it's like a NOC for your data, a network operational control center, but it's for your data, and it helps treat it like a mission critical asset that it really needs to be treated like these days. So why is Excel data different? Well, I talked a little bit about this shift left data reliability, right? We can isolate problems before it hits that consumption zone. We cover data at rest, data in motion, and data for consumption. And we're the only tool that does that. It helps you give you that ability to work with all these variety of sets of data in their various forms. We give you this multi-layer data for this root cause analysis up and down your data stack, and to be able to quickly resolve problems and incidents. We offer you these advanced policies around reconciliation and drift. That is very, very, again, unique to what we do. And then we also have a highly scalable architecture, right? We have a Spark-based architecture underneath the covers that can process huge volumes of data. And we've got customers that have these huge volume proof points that allow us to be able to stop and say, no matter how big your architecture is, no matter how big your data volumes are, we can make sure we can do these data quality and data reliability checks for you without impacting your systems. So let's quickly throw out poll question number 3, which is, what is your biggest data reliability challenge? You can choose one of these 6, please, which is, is it quality testing more data sets, right? Or do you need to run more quality tests on your existing data sets? Do you need to just overall increase your data quality scores? Do you need to make sure your data is far more fresh and timely? Or do you want to reduce the time that your data engineers are spent firefighting so that they can go off and do other things and spend much more time innovating around your data?
Yep, great. People are actually filling out the poll, so thanks a lot. We also did add an additional option, which is all of the above, which I see that some people are filling out. So we'll just wait a couple more seconds and then we can look at the results. All right, I'm going to end the poll.
Okay.
So if you have not answered, please do so. 3, 2, 1. All right, and then let me just share the results real quick so we can talk about them a little bit.
Boy, a lot of all the aboves there. I like that. Yeah, I mean, because again, with our increasing world of data and the need for the reliability of all of that, a lot of these are issues, right? Your data engineering team and your data engineering costs are constantly growing, going through the roof, right? So you'd like to have them spend more of their time, less time firefighting and more of their time innovating, right? Timeliness and fresh data is becoming far more important as well. I talked a little bit earlier about that business model, right? And more of you folks are moving to those business models. How can I be more agile in terms of what I do? So one example of a customer of Excel data who's using our products in and around data reliability is a global leader in financial information. They publish data assets. So they have a data product that they publish to a lot of financial institutions and banks, et cetera. And those banks and those financial institutions use this data with their own data in order to be able to make a lot of decisions, right? One of the key aspects around them producing this data product in having customers use this data is the FTC put together a whole set of guidelines around data quality. And they have to report on the quality of their data. So in order to meet these FTC guidelines, they had to put in place a lot of data reliability processes, a lot of data reliability policies, et cetera, and make sure that the data was of the highest level of quality to meet these FTC regulations. If they weren't in compliance, not only could they get fined, but then again, they could slowly but steadily be told, sorry, you're not allowed to do this anymore, right? Or one of the key aspects they also told us was their biggest source of customer churn was poor quality data. If the customer perceived that the data was not of the best quality, that customer would churn. So 2 reasons why they absolutely had to have the highest level of data reliability. And so they used our products to improve the automation of how they did data reliability, to actually get better engineering outcomes, to get their engineers to be able to work more efficiently, more effectively. They dramatically improved the speed by which they created rules and improved their overall quality coverage. And this is also in an environment that is of 4 petabytes, a huge sets of data volumes, right? And they also had much faster data quality checks. It used to take them almost half a month to run their data quality checks. Now it's in less than a day. And they're able to do a lot of other things to process these big volumes of data in order to be able to ensure that, that they're able to get that level of quality. And they literally call their data and what they produce a data supply chain. And again, Excel data is instrumental in that, to making sure that that data supply chain is working properly. So let me quickly go back to say, hey, look, quick commercial, who is Excel data, right? We've been around since 2018. We've had a few funding rounds, raised over $45 million. We are growing exponentially as a company because data observability and data reliability is a huge aspect of what goes on in your modern data stacks, right? We've got a great leadership team that comes from great companies, so a great heritage and a great knowledge set. And we're the only complete stack for data observability on the market. And we've got a lot of great customers that can give you proof points in terms of how they're using our products to be successful. So a couple quick things. One is we've got a whole bunch of great data reliability content up on the Excel data website. Let me quickly show you what that page looks like. So you can see here, this is the web page I mentioned, exceldata.io/data reliability. A whole bunch of great content here. You can learn a little bit more, and some other great resources down at the bottom, whereby, again, you can learn a lot more about how we can help you solve your data reliability issues and data reliability solutions needs. And then the other key aspect I wanted to mention is in a couple weeks, we will be having an in-person hands-on workshop. So folks of you who are in the Bay Area who may be interested in saying, hey, I'd really like to see how this product works, and I'd really like to do it myself and learn hands-on how to use this thing to solve data reliability problems. And in this case, data reliability issues and data reliability solutions on top of Snowflake. Well, we're having this hands-on workshop in San Jose. And again, you can go to go.exceldata.io/snowflake-workshop to sign up for that. So with that in mind, I'd quickly like to do one last poll question, which is, how much of your time or your team's time do you spend troubleshooting data reliability issues? Less than 20%, 21 to 40%, 41 to 60%, 61 to 80%, or 81 to 100%. And if you quickly kind of choose one of those, that's our last kind of poll question of the day, and we'll move into having Joe do our demonstration.
Yep, we'll give a couple seconds. People are still answering the question. So we'll close the poll in 3, 2, 1. and hear the results.
Well, hey, this is good, right? You've got a whole bunch of folks that are less than 20%. So that means your teams are working hard, doing a great job and stuff like that. So it's very heartening to see this data, the fact that you're able to spend less and less time troubleshooting these and fixing these problems. That's good to see. Congratulations to all of you. Joe, I'm going to hand things over to you so that you can show us the demonstration.
Before we do that, we do have one question from Jim. So let me, Joe, while you're prepping the demo, let me just throw this question out to both of you, which is, do you integrate with other data governance tools like Purview for attribution and classification?
So I'll grab that one. We have done integrations, say with other catalog tools. We can apply and deliver our results to other tools. We're open in terms of providing a full suite of APIs for integrations. So the short answer is yes, we provide all the integration points. We're a relatively young company, so we're driven by our clients that are asking us what integrations to do.
Awesome. Thanks, Joe. And anyone else, if you have any questions, again, please put them in the Q&A or in the chat window, and we will take those questions after Joe's demo. Thanks a lot.
Okay, so great. So I'll just confirm you can see my screen. Give me a nod, Loretta.
Yep, all good.
Okay, good. I always have to check that. I forget to hit that final share button. So I'm going to try to connect the dots a little bit from John's presentation, and then understanding some of the answers that you gave of the poll, saying, hey, a lot of you already have tools out there for data quality. Why is this different? Is this just another one of the tools? So I'll try to really bring out how I believe we are different about this, and some key aspects of how you might end up using it. Now, as John said, we have lots of entry points into the platform, right? So you could start looking at, I want to understand how all those types of data reliability policies have been executing this month, or maybe I want to zone in on what's happened in the last week and see, how am I doing? How many are passing? How many are failing? Or even zone all the way into what's going on today, right? So I have the ability to sort of move around this platform and get a view, right? I could say, hey, I want to drill farther into, say, how my policies themselves and get additional detail about, maybe in this month, what my coverage is, what tables are getting updated, et cetera. And I can see all sort of these management pieces. But I like to say we're striving to build this platform to be much more operational, not make you drive your data platforms, by a dashboard, but be alerted and brought into the platform when things are happening, right? So a key aspect of that is our ability to have a rich alerting framework that'll bring together all of the signals from the different layers that John talked about, right? These could be the pipeline or process layer, the pipelines that are moving it, the underlying compute layer, or even the data reliability layer. So I'm just going to filter that down to show the alerts I'm receiving about data in my landscape that I'm having alerts. Now, again, this is in our alerting framework, but these alerts will flow externally, maybe out to people's email baskets, maybe out to their Slack channels or their ticketing systems, right? So we have integrations and webhooks to send this data out to whatever way, say, your data ops team is operating, or specific data stewards need to get their information. So I may want to take a look at this particular asset. It's a table in one of my data warehouses that's critical to, say, one of my reporting platforms. And I saw that we got an alert that got fired about a data quality policy. And I have the ability from this alert to move to action, right? So the key thing is, how do I get to where I need to be to take some action? So here I can jump with related links to a link for that specific asset, or to the specific policy that was executed related to the asset. Now, for us, a policy, whether it's around the quality of the data, our ability to reconcile the data, our ability to detect drift in the data schema, et cetera, that's all aimed at executing multiple rules, multiple tests that will deliver a business intent. That could be, hey, I'm ingesting some data. It must have a minimum quality before I move it through my pipeline. Or I've processed that data. Now I want to do a detailed reconciliation from source to target, or test certain aspects to make sure that maybe the data values didn't drift, and I need to notify somebody about that. Okay, so I drilled from an alert right into a policy for this particular asset. This happens to be a table in Snowflake that we've tested. We've created multiple tests that are, around, I'll say, the table stakes of data quality. So a lot of you guys have data quality tools already. So you're familiar with sort of the 6 dimensions of data quality, the traditional thing. Our key aspect is, one, let's get more coverage. Let's make it easier to get that coverage and develop it. And then let's be able to do that at scale repeatedly in an operational fashion, right? So here I've got all the executions of the policy lined up for me. I can see the green ones have passed a threshold I've set. So we've got a way to, score based on all the rules. Well, I even highlight for you for each execution every record of data that failed a data reliability test for you. So as you move to action, you can kind of look, okay, I need to jump back to here where I actually fell below my target quality, and it'll allow me to drill into the actual records. I can even drill down to start saying, hey, I want to see which ones failed this test, and give me the actual records that failed this very specific test, and I can explore all of those. Okay, I can even have segmented analysis done for this to help me identify maybe this segment of the data has higher error rates than another segment of the data. So again, let's help you identify very quickly where the source of my problems are, right? Now, let me jump in. This policy, again, is made up of many rules that combine to allow you to build a business intent around a policy. And our goal here is to be able to allow you to do this in a no-code fashion, right? So point, click, generate these rules. We'll give you these recommendations. We even have a way to automate the generation of a full policy based on your specification of rules for a certain type of data and our identification of that type of data. So again, the drive here is to get more coverage so you can drive and automate the reliability of your data. Now, in this case, I want to take a look at the actual asset. So again, John mentioned we build a rich metadata catalog about the asset, really try to build a 360-degree view of the asset. Now, this popped me into a profile page, and if you've got data quality tools, you understand what a profile is. We gather statistical data about the asset, the columns, the fields, what percentage nulls. Now, we store many profiles of the data, and we do this as the data arrives in the asset, so we can start identifying how the data is shifting, right? Maybe the average value of a transaction starts shifting over time. We can alert you on that, right? We also start looking at the cadence of the data. So this is showing me what's the change in row count over the last day. We've been consistently getting data, which is what we expect. We can look over the last week. We can see, hey, there was actually a dip in our flow of data. And we can even look back to say, in this window, we actually had a stop where we weren't getting data into our asset, our pipeline probably broke at some point in time, right? And where we're going is we're actually going to identify the pattern of the update, the cadence of the data, and then alert you to anomalies in the pattern. So you can conceive of scenarios where you have cyclic updates of data, and maybe those stop or they bulge, and that may be seasonal. Wouldn't it be great if we can identify those patterns and predict when you deviate from those patterns? So again, lots of things go into what we consider as reliability of understanding the reliability of your data. Now, this particular asset, you can attach many different policies to, right? So as John talked about those types of checks we may want to build up to understand the reliability, it could be the data quality policy. That's the one we were just looking at with a variety of tests and understanding each one of those. It could be a reconciliation policy where we're testing the data came from point A. Did it get to point B? Did it get to point B correctly? Not just a simple, hey, I had 10 rows or 10,000 or 10 million rows, and did I load them all? But did I load them, and did I load the data from column A into the target column A correctly? And can I tie those together, right? No data got left behind. And I may even understand and monitor for changes in the schema. So my pipelines, one, they could be resilient if you're using modern integration technologies. A lot of them are resilient against schema change or drift in the schema. But what happens in many of those is they leave data behind. A new field showed up. Well, that's great. We don't break our pipeline, but we're not bringing that forward. So being able to identify those changes helps you understand that you're not leaving data behind. Now, I'm going quick because I want to wrap this up and give time for questions. You may want to start thinking about this particular asset and where it came from. So we can capture a lineage of this asset, right? So this is the table, and we've captured information about jobs that are processing it, as well as assets that are upstream from it, as well as downstream. And we get this lineage from a couple of places. One of the places we can gather lineages from, say, query logs of like Snowflake. The other is our ability to capture that from pipelines, right? So we've actually connected our view of a pipeline, the pipeline that is populating this warehouse table for me. We've connected that with the asset, right? So if I click on this, I'm brought into a view of the pipeline that is populating this particular table. Now, this particular pipeline, and just to explain the view, these white boxes are actually, think of these as jobs or tasks in your pipeline, where the blue boxes are actually assets in the pipeline. So I can now see that this job actually starts gathering some data from some APIs, landing it, flattening it, gathering additional data, merging it into a number of tables in my warehouse. And then at the end of this, it's actually triggering the data reliability policies that I was just showing you, right? So it's actually building into the pipeline itself, sort of the circuit breakers, right? I've loaded this data, run a data quality job or run a recon job to make sure it's accurate. So then I can either raise an error before I publish my daily dashboard to my application or something like that, right? So I can build that intelligence into the pipeline. I can get a view of how the pipeline is running over time, each step along the way, understand detail about it. I can start looking at how each of the nodes, do they have data quality on them? Do they have drift? Are they passing their tests? I can look at each one of the steps along the pipeline. I can look back at all the different executions of the pipeline, even back to failed executions of the pipeline. So I can answer the question of how did this data get here today? What happened in a specific run of the pipeline, right? I can even compare for timings of one run against the other. I can drill from here right into, hey, I want to take a look at that asset. This particular run had a data quality issue. I can see some summary information, and I can bridge right to the policies or back to that asset we were just looking at, right? The other thing I can do from the pipeline view, let me collapse that. I can actually set some monitors on this specific pipeline. So I can create a baseline around what's the expected runtime of this pipeline and alert if I start deviating from the expected runtime. I can even set individual tasks, alerts on individual tasks within there, and either have them have absolute times or relative time monitors to say, hey, this should take 20 minutes, and if you go beyond, alert me. Or if this starts varying by 50%, alert me. So I can get very proactive about understanding where problems are occurring in my pipelines. Okay, let me go back. There we go. There we go. Okay, so I've hopefully tied a couple of those elements together. There's a few other things I want to touch on, some subtleties and some power of our platform that help drive more capabilities, right? So we talk about things like reconciliation, right? So I want to just bring up a transaction file for a second, a different asset. So we're not just always looking at the same asset. This just happens to be, say, credit card transaction data. I've profiled it over time. We identified anomalies, things that have sort of gone out of normal parameters, and I have a number of policies like before. One of these policies is doing things like, I'm going to reconcile a file that's sitting in S3 against a table in Snowflake, right? And that could be a reconciliation that says, hey, not only do I want to make sure that the data came from the file, this is transaction data, but when it was loaded into Snowflake, nobody changed the account number or the company or the transaction type code or the amounts, critical elements that aren't just row counts. I want to be able to audit myself back, right? I can do drift policies that say, hey, I want to be notified if this data starts drifting, like the transaction amount, the average amount starts drifting more than a certain percentage. I want to know about it because that may affect some other downstream processing. It may be important business information, right? The lineage for this particular one actually shows that we're actually taking this data and creating an aggregate for it. Maybe I'm loading this transaction data into an aggregate. I can even show from that query log detailed lineage to show how the data, the individual fields are moving across, right? Now, what I really want to do is make sure that that aggregate is reconciled back to the transaction detail. Now, this has been summed up. And how would the question is, how would I actually do that aggregate, that reconciliation? So if I'm looking at this transaction asset, I can look at the quality tab and I have a data reconciliation policy. And if I look at the past executions of the policy, the last one was successful, but if I go to the previous one, I can actually see it was unsuccessful. So I was not able to reconcile the detailed transaction data I had to the aggregate. And I've called out below the individual records. And if you looked at the posting dates, it's actually a certain month didn't get aggregated. So think of this as, hey, I'd run this on a monthly basis and I forgot to run, or the pipeline didn't run, or whatever automated job that creates that aggregate didn't happen, right? So I can be alerted again to say, hey, I can't reconcile an aggregate back to the underlying data that was supposed to build it. So the question becomes, well, how do you do that, right? So if I took a, whoops, that's Murphy's Law, always causes you to have one little burp in a demonstration. So if I look at this particular policy, you can see this is the target table, but I have this other asset, and I'll click into that. And this is what we call a virtual asset, right? So this is a virtualized asset built on top of that underlying transaction data, right? In this case, it's a simple SQL query that's built. This could be a very complex query that joins multiple tables, filters data in any number of ways to create a more complicated asset. But in this case, I've kept it relatively simple. It's basically creating the aggregate, creating an aggregation on the raw data. So as the raw data, the transaction data changed, this would always be accurate. Now this one, again, it becomes a first-class entity. I can profile it. I can put policies, including reconciliation policies, right? Now, that's sort of a very straightforward, hey, you can do it with SQL, but we also have a virtualization capability that we call our visual views. And let me just filter myself down. And if I take a look at the same sort of scenario, this particular visual view gives me a visual way to start building up these joins and aggregations. So in this case, I've joined a file actually on an S3 to another file of reference codes, and then created aggregation on that, and then joined that to a Snowflake table. So I've taken multiple files and tables, and I can keep building this out and created a virtual asset. So think of this as a lightweight dataverse virtualization capability that can help you do things like reconciliations for a process that may bring many things together. The very last thing I'll show, because Loretta's going to cut me off for some Q&A, is the cadence. Whoops, wrong button. The data cadence, right? So with a data cadence view, I can start looking at how my data has been accessed across a number of different dimensions. So I might want to look at data that's being, with a metric that says how often is the data updated against who's reading the data, right? So if I look at the data this way, I find that this particular asset is being read the most in my platform, but hasn't been getting updates. This data may not be fresh. Maybe people are looking at the wrong item. I may also want to start looking at data that is getting changes in record count, and start looking at, hey, what's happening up and down with the data, and help me understand ones that have sort of high query usage but low coverage on their policies, high record counts but low coverage. So I can help identify what's going on with my data. I can filter this down a number of ways to zone in on specific data sets and really get a deeper insight into what's happening in the data, where I have gaps in my coverage, et cetera. So that was sort of a quick run through of the platform. There's a ton of capabilities from the pipeline observability perspective and looking at all your pipelines and how they're running, to the compute side of the house. If you have Snowflake, if you have Databricks, we can help you understand what's going on there, and then to manage your alerts, bringing all those signals together to help you drive your data ops team and drive reliability across your landscape. So with that, I'm going to stop talking and see what kind of questions we have.
Great, thanks, Joe. Yeah, so we do have a couple questions. One question, you talked about the pipeline, which is, do we integrate with data orchestration tools like Argo or Airflow with the pipeline functionality?
Yes, we do. So we have a very specific Airflow SDK to allow you to plug in and have specific Airflow operators, so you can do things like drive. Here's a more complicated DAG, if you will, or pipeline. You can then drive within those policies and make those circuit breakers for you. We have a general Python SDK. This particular pipeline is actually a combination of a Databricks flow as well as an Airflow DAG. So the front half of this is actually driven in Databricks, and the back half of this particular pipeline is in Airflow. So we have a number of strategies on how to do that integration.
Great. You also talked about alerts. So what alerting systems do you integrate with?
So we can alert out to Slack, Google Chat, emails through webhooks. We're in the process of, usually when people want to go to a ticketing system, they'll ask for a webhook. There's a number of other strategies to have that flow in via like an email channel, etc. But we're also doing a specific integration for ServiceNow so that we can have a two-way integration. So when we send them something to open a ticket and they close it, we can close it back in our own system. We do maintain all those alerts on our side and give you analysis across it, have a number of ways to create the monitors that we start looking for those alerts. I showed you in the pipelines how I could create specific situations to be alerted on, raise an alert when this span or this particular task goes over time. We also have that very specifically in the compute range. So, hey, if you have Snowflake queries that are running away on you, we can alert on that. We can even start taking auto actions if you wanted us to go, hey, if this Snowflake query is on a runaway path, we can go delete it, stop it for you.
Great. So just a couple more. What does the implementation of this look like?
Sure. So this, we offer our Excel Data Observability Cloud. There's two key components in this, right? There's the control plane. That's the multi-tenanted control plane. This is the application we're in that you see. When we do these data reliability policies, we deploy what's called a data plane, right? So this is a set of components that would reside within your own environment, say your own AWS VPC, where this component is what would touch your data, do those evaluations of the policy tests, right? That's the component that would touch your data. That would always reside in your zone, right? So it's deployment, and we have that an automated deployment process for that. Once that's deployed, basically, there's a number of steps to say, hey, we're going to define our data sources. What are we going to catalog? We'll scan those automatically. You can turn on automatic profiling if you want. And then we can start working on building the business intent, the policies. And again, our goal is here, help you automate that, make it as low code, no code as possible.
Great. And actually, I think that what you just mentioned segues into the last question, which is, does the data stay in our environment, or do you take the data out of our environment?
The data stays in your environment, right? So we don't even stage data. Like when we're doing our policy, we're running Spark engines and bringing that up in memory. So the only thing that flows back to the control plane is metadata. Basically, hey, this was the policy that we ran. These were the results of it. In part of my demonstration, I showed that we can display the results of a policy, not just the score, but if you need to see the actual records that violated test, you can configure whether we do this or not. And we take that, those data violations, and we'll write those to Parquet files in your environment. So that data never leaves your environment either. This can be very useful. As John was saying, hey, you need to go take action on these problems. one of the use cases, the client he talked about that had these huge volumes of data, they bring in lots of data. They use this process to write out the bad records, we'll call them. They actually write out the bad and the good. They process the good records, that were evaluated, and then route the bad records back to their source. Now, a key thing is we do not change your source data. So if you point us at a Snowflake table, you point us at an ADLS Parquet file or JSON file or a Redshift table or BigQuery or a MySQL table, we're not changing the data in there, right? For these data violations, we'll write that out to your location for you, but we don't change the source data. Okay.
Great. All right. I think that's all the questions, and we're at 1 minute after. So I just want to be cognizant of everyone's time. Thank you so much for attending. We appreciate your interest in giving us your time. Just a couple follow-ups. If you are interested in the live Snowflake workshop that John mentioned, you can register on our website. And if you would like to get more information, again, please go to our website and complete the contact us form, or feel free to email me directly. It's Loretta, LORETTA @exceldata.io. So thanks, everybody. Have a great day. Again, thanks for your time. Bye-bye.
Thanks.